Hello, I'm Ed Close. Welcome to another in the series of videos answering quantum questions. If, as Planck said, there is no matter as such, then why do elementary particles exhibit mass, and how do we explain the existence of gravity? If I weigh 180 pounds on the planet Earth, I'll only weigh about 30 pounds on the Moon. Why is this? Do I lose mass in going from the Earth to the Moon? In this video, we will see how this is explained by multidimensionality and particle spin. In the process, we will answer some related questions that have puzzled physicists for decades. Now, if weight is not mass, what is mass? When I was an undergraduate physics student, I was fortunate to have a physics instructor. His name was Professor Abernathy, who built all of his own lab equipment. He actually enjoyed, he was a great instructor. He enjoyed surprising us with various kinds of learning experiences. One day when we walked into the classroom in Physics 101, there was a large, oversized briefcase sitting at the back of the room. After we had all been seated, he asked one of the students to get that briefcase and bring it up to the front of the room and over to his desk. Well, the student picked up the briefcase. It was kind of heavy, but she had no problem with it until she got up to the front of the room and tried to turn to her left to take it over to Professor Abernathy. She had no problem turning, but the briefcase wouldn't turn. And this was very puzzling. We hadn't seen anything like this before. So he had all of us take turns, and we would pick up this briefcase, and as long as we walked in a straight line, it was fine. But if we tried to turn, it resisted that turn. So after we had all tried this, he explained to us that we had just experienced firsthand the gyroscopic effect. And then he proceeded to show us what he had done. He had mounted a flywheel inside this briefcase, and just before class started, he had set it spinning at a high rate of speed, and he had this fixed so that you didn't hear anything. He had it, insulated, and there were bearings and everything, so the wheel was spinning, but we didn't realize that. And so it seemed very strange that this object would go in a straight line, but if you tried to move it, tried to turn it, it would resist that. He went ahead to show us how the gyroscopic effect works and showed us with a smaller gyroscope how it would defy gravity. Clearly, a large number of particles linked together spinning at near light speed will exhibit a resistance to motion. But how is the gyroscopic effect of an elementary particle conserved when it's not being observed as a spinning particle? As we know from quantum physics that it isn't a particle until we set up the equipment to measure it or to observe it. The simple two-slit experiment and a number of more complicated and sophisticated experiments demonstrate that the substance of reality can be coaxed into showing itself as either particle or wave, either spinning object or vibrating field, either local or non-local phenomena, depending on how the conscious observer chooses to set up the experiment. Niels Bohr called this fickle feature of reality complementarity. In his discussions with Einstein on the epistemological problems in atomic physics, he said, however far quantum phenomena transcend the scope of classical physical explanation, the account of all evidence must be expressed in classical terms. Consequently, evidence obtained under different experimental conditions, he's talking here about to see particles or waves, cannot be comprehended within a single picture, but must be regarded as complementary in the sense that only the totality of the phenomena exhausts the possible information about the objects. In other words, these are two different pictures, but they complement each other to tell you what's going on with the particles. Now, Bohr was known for wordy and sometimes confusing statements, but I wanted you to hear his explanation in his own words. Bohr's complementarity has been interpreted as meaning that quantum phenomena are dualistic in nature, that is, both particle and wave, until it's observed. But in DVP, based on the math that we've developed, we see that quantum reality is triadic. It's particle or wave upon observation, depending upon the observer's choice, but neither without observation. Not both of them superimposed, like in the Schrödinger cat experiment, but in a third integrated spinning state undefined in the current paradigm. But in this way, mass and energy are conserved, but also, very importantly, stability is conserved. In order to understand why there is no matter as such and how seemingly separate elementary particles are connected, we need to briefly explore something that I call dimensional connectivity. We have demonstrated that some things are inexplicable, that are inexplicable in the current scientific paradigm are readily explainable in a 9-dimensional spin reality model. In the previous video, for example, we saw how the one-half intrinsic spin of fermions observed in the 3-dimensional domain available to our physical senses is explained by recognizing that fermions may be spinning in 9 dimensions. Other things that have puzzled scientists for decades, like quark mixing angles, particle stability, and action at a distance, are also explained by a 9-dimensional model of reality. Action at a distance phenomena have always puzzled physicists. There seems to be no mechanism to explain cause and effect phenomena that are not physically connected. But objects that we observe in 3 dimensions through the physical senses and perceive as completely separate may actually be connected through the additional dimensions of reality. Now, this is an example in this picture of a 2-dimensional domain, a plane, and it's observed from the 3rd dimension. And observations, you'll see that a torus-shaped object, that's a donut shape, moving from left to right in this slide, can appear as separate circles. These are the yellow circles in the figure. In a 2D domain, in other words, the plane, but observations limited to that 2-dimensional plane will reveal the circular objects behaving as if they were connected by some strange force acting over the distance that separates them. It is only when we are aware of the 3 dimensions, of the 3rd dimension, that their connectivity becomes apparent. In the same way, the limitations of our physical senses to 3 dimensions obscure most of the evidence of 9-dimensional connections but there are subtle clues in the behavior of galaxy rotation and in quantum particle spin effects. When we view the spinning elementary particles of the three-dimensional physical universe from the perspective of a nine-dimensional reality, we can begin to understand how Planck was correct when he said there is no matter as such. What we call matter, measured as mass, is not really material at the quantum level. What is it then that we are measuring when we weigh a physical object? The real measurement of mass is not weight, which, as we saw, varies with relative location, and it also varies with velocity, as Einstein showed. And it can be zero without any loss of substance and out in deep space. The thing that we're measuring is its inertia, the resistance to motion, like the way the briefcase resisted being turned out of its line of travel. The illusion of solid matter arises from the fact that elementary particles resist accelerating forces due to the fact that they are spinning like tiny gyroscopes, connected particles, and they resist any force acting to move them out of their stable planes of rotation. Dimensionally connected particles spinning in perpendicular planes resist movement in any direction, and the measurement of that resistance is interpreted as mass. Now, using TDVP principles, we can actually predict the relative masses of the three smallest possible elementary particles. Think about the three smallest particles. They would be 1 true unit in radius, or 2, or 3. Those would be the first three particles. And the resistance of movement of these particles, the inertial mass, would be proportional to the area of the cross-section of the volume that the particle occupies. In other words, the plane that it's rotating in. Now, the area of a circle is pi times the radius squared. Now, I'm not apologizing for this little bit of math because it is simple and should be familiar to anyone who graduated high school. Since pi is a factor in all three cross-sectional areas, it is easy to show that the predicted relative inertial masses of the three smallest possible particles are 1 squared, which is 1, 2 squared, which is 4, and 3 squared, which is 9. So the smallest particle will have 1 true unit of mass. The second, the largest one, will have 4, and the third, smallest in size, will have 9 true units of mass. Now, let's determine the relative mass of these three smallest elementary particles from particle collider data. The mass of the free electron is one of the best known constants of nature. It has been very accurately and precisely determined, and in the conventional units, which are mega electron volts divided by the speed of light squared. That's the unit that's normally used in physics. Now, I'll just call that MeV when we go on for short. Taking the mass of the electron as the true unit mass, we set it equal to unity, to 1, and determine the masses of the up quarks and the down quarks as multiples of that unit. In this way, we have normalized the relative masses of the electron, the up quark, and the down quark to true units. Using the latest available statistical data from the particle colliders, the mass energy averages for the up quarks and down quarks are 2.01 MeV and 4.79 MeV, respectively. Dividing by 0.511, which is the mass of the electron, to 3 significant figures, and rounding the result up to the nearest integer value, because we know they have to be integers in true units, we have normalized mass energy equivalents for the electron and the up and down quarks. And when we do this, guess what? They turn out to be 1, 4, and 9 true mass units, respectively, exactly the values that were predicted by the theory. Now, in conclusion, we agree with Max Planck that there is no matter as such. Mass is simply a measure of the inertia of spinning multidimensionality, connected energy vortices, and therefore mass and energy are the same thing. In upcoming videos, true units of the third form and how they relate to life, consciousness, and the shaping reality will be subjects that we will explore. So I'll see you next time on Science and Spirituality TV.